In this lesson, I'm going to be going over how to simplify square roots. These are some problems that I've taken from CUDA software, and I'm going to use these as my examples. A good thing to do before, or a smart thing to do before you start simplifying square roots is by making a list of all of your perfect squares. So I'm going to do that along the right side of my paper here. The smallest perfect square is actually 1. Oops, I need to get my pen going here. All right, so the smallest perfect square is 1. The square root of 1, though, is equal to 1. So that really doesn't help us simplify square roots. So we will not be using 1 as a perfect square when we're simplifying radicals. The next perfect square would be the value of 2 squared. Well, 2 squared equals 4, which means the square root of 4 would equal 2. The next number, 3 squared, would be 9. So the square root of 9 would equal 3. After that, I would go, square 4. 4 squared is 16, meaning the square root of 16 equals 4. The next perfect square would be 5 squared, which is 25. And the square root of 25 is 5. After that, you've got 6 squared, which is 36. The square root of 36 is 6. 7 squared is 49. The square root of 49 is 7. 8 squared is 64. So the square root of 64 equals 8. 9 squared is 81. So the square root of 81 is 9. 10 squared is 100. So the square root of 100 is 10. I'm just going to go a little bit further here to about 15. So 11 squared would be 121. The square root of 121 would equal 11. 12 squared is 144. So the square root of 144 is 12. 13 squared is 169. The square root of 169 then is equal to 13. 14 squared is 196. The square root of 196 is 14. 15 squared is 225. And the square root of 225 is 15. So those are the first 15 perfect squares. And when you take the square root of them, you get the root, which is these numbers on the right. Besides being able to simplify perfect squares, square numbers, you also have to be able to simplify the variables. So the smallest variable that is a perfect squared is a variable that is squared. So I'm just going to use the variable x. So x squared is a perfect square. When you take the square root of x squared, the square root and the square basically undo each other, which is why you get x by itself, or x to the first. The next perfect square would be x to the fourth power. And the square root of x to the fourth power would equal x squared. The next perfect square would be x to the sixth power. The square root of x to the sixth power is x to the third power. The next perfect square would be the square root of x to the eighth. And when we take the square root of x to the eighth, we get x to the fourth. So we'll just do one more. This x to the 10th is a perfect square. And the square root of x to the 10th would equal x to the fifth. So that's a little bit of a few examples on how it works with variables. Basically, the square root has a root of 2. So even though 2 is the unwritten root, we don't have to write it down. When you do take the square root of a variable to an even power, you just divide the power by the root and you get your new exponent. All right, so now let's go through some of these examples. So in example 1, we have a square root of 54. So I'm going to show you a couple of different ways of simplifying square roots, and it kind of depends on the size of the number that you're trying to take the square root of. So one method or one approach would be to make a list of the factors of 54. So we do this when we're factoring polynomials also, but so this is one method that I've used. So 1 and 54, 2 and 27, 3 goes into 54 18 times, 4 does not go into it, 5 does not go into it, but 6 goes into 54 9 times. So now that I have all the factors of 54, I'm going to look for ones that are perfect squares. Well, 1 is a perfect square, but like I said earlier, the square root of 1 is just 1, and then we would still have 54 left over under the square root, so 1 is not going to help us simplify. If I look at the rest of these factors of 54, the only other one that is a perfect square is 9. So that's the one that I'm going to use. So I'm going to basically factor the square root of 54 into the square root of 9 times the square root of 6. The square root of 9 now becomes 3 because that's a perfect square. When we take the square root of it, we now get a whole number. But if you think about the factors of 6, 1 and 6, 2 and 3, again, 1 is a perfect square, but it's not going to help us reduce. 2, 3, and 6 are not perfect squares, so the number 6 does not have any perfect squares other than 1, so it cannot be simplified. So the square root of 54 then, in simplified form, is 3 square root of 6. Our next example is 32. So again, I'm going to use the same approach. 32 is kind of a small number, so I can list the factors of 32, 1 and 32, 2 and 16, 3 does not go into it, 4 goes into it 8 times, 5 does not go into it 6 nor 7, but I do have 8 already on the other side. So these are all of the factors of 32. So I cannot use 1 when I'm simplifying radicals, but I do have a couple other numbers that are perfect squares. So 16 is a perfect square, 4 is also a perfect square. When you are simplifying square roots or radicals, you want to use the largest perfect square or the largest perfect cube or whatever it is that you're simplifying. So I'm not going to use the 4 and 8 because then I'd have to simplify the 8 a little bit further. So I'm going to use the 16 and 2. So I'm going to factor the square root of 32 into 2 square roots. So 32 can be factored into 16 and 2. The square root of 16 is 4. And then you've got your square root of 2 that cannot be simplified. So 4 square root of 2 is your solution there, or your simplified radical. Okay, the next example that I'm going to do is example 3 here. So 384 now is a pretty big number, and I'm not going to just want to list all of the factors of 384. So this is where my second method of simplifying radicals comes in. I'm going to think about what my perfect squares are. So I can always start with 4. 4 is the smallest perfect square that you could use to simplify radicals. So I could take that 384 and divide it by 4. So I can, like I said, I can factor the 384. It can be divided by 4 evenly. And then when I do divide this by 4, now I'm going to get a smaller number, 96. Now we have our variable. The variable to any variable to an even power is a perfect square. Well, n to the third is not an even power, but I can factor the n to the third into n squared and n to the first. So far now I have a perfect square of 4. So the square root of 4 now I can convert to 2. So now it's a whole number. I'm done with that piece. The square root of n squared is n to the first, or just n. So I'm done with that. But now these two parts, the 96 and the n to the first, are still underneath the square root because they are not perfect squares. So now it's a time to ask yourself, can I simplify this 96 any further? So 96 is a little bit smaller than 384, but it's still a pretty large number. So I could divide by 4 again, or I can try maybe dividing it by some larger numbers. So for example, I could try dividing by 4, which 4 does go into 96, but I can try dividing by 9 or 16 or 25 to see if maybe there's a larger perfect square that is a factor of 96. And in fact, there is a larger number than 4. 16 is a factor of 96. 16 goes into 96 6 times. Now notice when I'm doing this, I've always put the perfect square first because that is when I take the square root of it and I simplify it, it's going to go in front. So the square root of 16 is 4. So now I'm going to multiply that by the 2n that's already on the outside. So I end up getting 8n when I simplify that. But the square root of 6, like we said earlier, cannot be simplified. And the first cannot be simplified. So those are the things that are now left inside the square root, 6n. So our simplified answer would be 8n square root of 6n. And just to point out, since 8 is the number that's on the outside, the largest perfect square that would have been a factor of 384, if we did make a list of all the factors, would have been 64. And how do I know that? Well, what's 8 squared? 64. So 64 times 6 would have to equal the 384 that we started with. All right, hopefully that makes sense. All right, so the next one now we have is 175 x to the 4th. So again, 175 is not a perfect square, but it does end in a 5. And if it ends in a 5, a lot of times I think about quarters. If you had $1.75, how many quarters would that make? Because 25 is a perfect square. So that's why I like to use quarters or think of quarters. So if you had $1.75, that would equal 7 quarters. So 25 is a factor of 175, and 25 is a perfect square. And then 175 divided by 25 is 7. The x to the 4th is a perfect square because it has an even root. So I do not have to factor that at all. So now take the square root of your perfect squares. So the square root of 25 becomes 5. The square root of x to the 4th becomes x squared. You're going to divide by 2. Remember, the root is 2, so take the power divided by the root. But the square root of 7 cannot be simplified, so that would stay square root of 7. All right, the next one we have is the square root of 180 x to the 3rd y squared. So now I've got 2 variables that I'm dealing with. So try to make it a little bit more challenging. So I might not know what the perfect square is, that the largest perfect square, that's a factor of 118, but I do know that 9 goes into 18, and 9 is a perfect square. So, wrong way. So I can factor that square root of 180 into square root of 9, and when I divide 180 by 9, I get 20. So now let's deal with my variables. My x to the 3rd is not a perfect square, but if I factor it into x squared and x to the 1st, I can then simplify the square root of x squared. So the x squared times x would equal x to the 3rd that I started with. 9 times 20 would equal 180 that I started with. Y squared is a perfect square because it's an even exponent. So now I can simplify that. So the square root of 9 then becomes 3. The square root of x squared becomes x. The square root of y squared becomes y. But 20 can be factored again. The perfect square, that's a factor of 20, hopefully you've thought about, is 4. So I can factor the square root of 20 into the square root of 4 and the square root of 5. This square root of x cannot be simplified, so I'm just going to bring that down. But now my square root of 4 becomes 2. I'm going to multiply it times the 3xy that I already had. So now on the outside of the radical, I have 6xy, but on the inside of the radical, I still have a 5x. So there's my simplified radical form. All right, the next one, again, we have a little bit bigger number. All right, so again, 392 is a fairly large number. So instead of listing all the factors of 392, I'm going to start by dividing by 4. 4 is the smallest perfect square that we can use to factor or simplify perfect square or square roots. All right, so 4 does go into 392. When you divide 392 by 4, you get 98. Now the square root of x cannot be simplified, but your square root of y to the third can. So I'm going to factor that square root of y to the third into a square root of y squared and a square root of y. All right, so going back now to the beginning, square root of 4 becomes 2. The square root of 98 is not a perfect square, but it does have a factor that is. And I know 98 is kind of a big number, but I know that if I divide 98 by 2, I get 49, and 49 is a perfect square. So I'm going to put the 49 first and then the 2. So the square root of 98 factors into square root of 49 and square root of 2. Oh, I also will have this square root of y squared. I probably should have put that up front with that 2. But then the x and the y are still going to be underneath. Those are not perfect squares. All right, so we just have a little bit more simplifying to go. The square root of 49 is 7. Multiply that by the 2y that's already been taken out. So we get 14y. And then inside the radical, you're going to still have 2xy. All right, a couple more examples to go. If you are feeling confident, go ahead and start working on the assignments. But for right now, we have a couple more. Now we have 3 variables instead of just 2. But 28 is a pretty small, fairly small number. So is 63. So when you have smaller numbers that you're familiar with the factors of, it again might be easiest if you just list your factors of 28. So 1 and 28, 2 and 14, 4 and 7. So can't use 1 to simplify, but 4 is a perfect square. So square root of 4, square root of 7. So I'm factoring the square root of 28 into the square root of 4 times the square root of 7. Because, again, this is a square root, the root is 2, you want the exponents to be even. So you want them to be divisible by 2 if they're perfect squares. So h to the 4th is a perfect square, so we can leave that alone. The j to the 3rd, we can factor into j squared times j to the 1st. The k squared is already a perfect square, so just k squared. So now anything that's a perfect square, I'm going to simplify. So the square root of 4 becomes 2. The square root of h to the 4th becomes h squared. The square root of j squared is just j to the 1st, or just j. And the square root of k squared is k. So what do I have left underneath? A 7 and a j. So the square root of 7j. All right, so we got one more. 63 can be factored into 9 and 7. So hopefully you knew that 9 was a perfect square. And the square root of 9 then is going to become 3. We'll do that in my next step. But I've got 3 variables, an x, a y, and a z. Well, the x to the 1st cannot be simplified. It's not a perfect square, so it's going to stay underneath. Your y to the 3rd, you're going to factor into square root of y squared and the square root of y. Z squared is a perfect square, so you're going to just leave that as z squared. So now when I simplify my perfect squares, the square root of 9 becomes 3. The square root of y squared becomes y. The square root of z squared becomes z. And then underneath my radical, I still have the 7x and y. All right, so I hope that helps you with simplifying your square roots.